Okay, now working our way through the options on the command line. The next one here, I've talked about the -n, that's the number of threads, minus path and minus license. When ADMET Predictor starts up, it reads from your app data local directory and to find the model files, etc. Now, if you're running this from an account that might not have a registry and it might not have directories, you can specify the path to the ADMET Predictor model files on the command line. So this is helpful in things like pipeline pilot programming. Similarly, your license information is stored in your registry on Windows. And sometimes that's not available to all users. You can specify a path to the license, and this would be something like @localhost to be the IP address of the license server computer there. The next option is the -out baseline or base name. So this can either specify the base name for the files produced, or you can also specify a directory. So if we just do ap12 -t smi -out example and then demo2d.smi, what that will do is simply produce an example.dat file in the current directory. So instead of a demo2d.dat file, it produces the other one. And then you can also specify a directory. The directory has to exist. So I'll make the directory and then repeat the command here, except out dir. Now here, if it ends in a slash, it's assumed, and also put a // here. Then it interprets that as the name of a directory, and so the output file goes into that directory. So let's just, when this finishes, cd into the example directory, and then you see demo2d.dat is in that directory. So that's a nice way to organize the files. Okay, the next few options, -cpt, -species, -symmodel HIA, -symmodel ACAT, and -PRM, are all related to running the HTPK simulation module. And I'll just go through these one at a time, showing examples. So before we look at these other options, we'll just look at what happens if I do -m symfafb. So the output here is this demo2d.dat file. We'll open that up in Excel. And what it does is it just goes through and produces the output for the fraction absorbed, oral bioavailability, Cmax, Cmin, Tmax, etc. The -cpt option will create a CP time curve. So if I execute this command here, I'm using 7 threads. The output file is going to be the dat file, which will contain the information about the %fa, %fb, and then this additional file, demo2d_.cpt. You can open up this file in Excel, and I've put a filter on these top row here, but it's going to create CP time curves, so the time and the concentration, also include the dose, and then for the species, human, mouse, and rat on the command line, by default, all of these are exported and then also are calculated. And then for each compound, it's also shown. So we could make a graph of all of the CP time curves. And of course, it's going to be pretty complex. So what you can do is you can go through and you can filter. So let's filter out mouse and human, or mouse and rat. And then now you're looking at all the compounds. Here we could just look at an individual compound. So you could kind of filter through that. The next option is the -species option here. And it simply limits the HTPK simulation output to a single species, or you could comma separate them, so you could use 2. If you use 3, that's the default, so you might as well not even use that option. but the arguments are either HUM for human, RAT for rat, MOU for mouse, and as I mentioned, these can be comma separated. Next, I'll discuss the option minus sim model underscore HIA and minus sim model ACAT. So you can create your own HIA files, and these files contain parameters for the HTPK simulation run. These HIA files are stored in your user app data directory. So my username is mlawless, app data local simulations plus, and then ADMET Predictor underscore 12. And so these are the HIA files. So you could take one of these and copy it to your local directories and then edit it. I took sim.hia. Now, once you get this working, you can move that file back into this directory. Any of these files here, there's also another copy of in the C program data directory, which I'll show here. So C data, simulations plus, ADMET Predictor 12. I haven't sorted them by type yet. But yeah, here's the HIA files. And this directory is typically non-writable. So it's the original files that were put down during installation. So I simply copied that file to my local directory. And then the only change I made was in this ref clearance attribute here. And so I added a my HLM underscore clint to this. It was sip HLM clint. So what this means is that if the input file has this column in it, it has to contain this column, then it will use the value in that cell. Now, and then this is the fallback if this cell is blank. So I'll show you the input file instances where I have values for this and other instances where it is blank, and so it'll use this backup one. I just want to tell you that this file is well documented. So if you go to the top of it, all the parameters are documented so you can understand what they are. Then on the command line, I would run AP12 minus T SMI minus N7 minus M sim FA FB minus species. So here I'm only going to use the human species, which makes the output a little bit easier. And then my sim HIA underscore HIA, I'm going to use the local file here. And then this is the input file. So let's take a look at that input file. So here's the input file, sim.smi. You can call it whatever you want. And then I've got another column or an attribute here, my HLM underscore clint. And then I've got 5 molecules in here, and each molecule has 2 rows. In one row, I have a value for this attribute, and in another, it's simply a blank. And then I would execute the command, and I've read the output file sim.dat into Excel, and you can see that here are the different names of the compounds, and then the oral bioavailability here, the myclint value, and you can see that some of these are blank, and each one is the oral bioavailability is a little different because the liver clearance is a little bit different. So the first pass extraction, and you can just see that those are all a bit different. So there's a lot of different options, different ways you can set up these HIA files. The last option related to the HTPK simulations is the minus PRM. This creates a file that indicates for each compound all the inputs used in the HTPK simulation. So if I use that same example I just used for the sim HIA file and just add this minus PRMT in here, what this does is it creates a sim, uses the base name underscore PRM .text file. And I've read this into Excel, so it'll list each compound, what the workflow is, species, row ID, then inputs such as molecular weight, diffusion coefficient, solubility pH, all the parameters. If we go over here a little bit further to the right, you'll see the clearance. So the clearance comes from either my HLM clint or the SIP HLM Clint model. And then also you get information on first pass extraction, which is not output in the GUI, so that's kind of nice to grab it here. And then the dose volume, particle radius, kind of characteristics of the API, and then the body weight of the subject, and then the simulated gastric and intestinal fluids. The last two options are -PT, which stands for pass-through. So if you feed it an SD file, it will attempt to preserve as much of the original records as possible in the output. So what used to happen is that it would convert the SD file differently, and so you'd lose the information you fed it in it. So this pass-through just says to keep as much as possible. And then the final option here is file.txt. And these are associated with command line argument scripts. And this is a very powerful way to run different ADMET Predictor algorithms on the command line. And so I'll show an example of how you would specify the command line input file. Documentation of the script files is in the ADMET Predictor 12 user manual in section 1.15.3, starting on page 105. And these command line scripts are to perform different tasks. So, for example, this one generates analogs, generates classes, filters molecules. Each one is well documented. So if you look at these files, it documents what it does and what the inputs are and the outputs. I'm going to just show an example of MS generate metabolites and how to run that on the command line. You take the arguments from here, and also a way to modify those arguments on the command line. All of these command line scripts are in your user app data local simulations plus ADMET Predictor 12 command line. So it's a separate folder or subdirectory, and it contains all of the text files that are documented in the user manual. Okay, I've copied msgenerate_metabolites.txt into my local directory, and I'll just go through the options in the file. In all of these script workflows, you'll see a process name and then the name of the command or the process it's running. Here we're going to generate metabolite. This is a field you would never change. And then pointing to the file path alias, so I can just get that information from the current working directory. So I'll just copy that from Explorer and paste it into the file. Then the input file, here I'm going to use a Smiles file called parent.smi. Let me show you that file really quickly. So it just contains two lines. The first line is a header line, Smiles and name. The second line contains a Smiles string and then the name of the compound, B1. We're going to leave the log file as metabolites.log, the output path or the output as metabolites.scf. Then this name field, since we're inputting a Smiles string, we want this to indicate the first column in the column in the file that contains the name. So the second column is the name column, so we would set that to 2. And then we would also specify that my Smiles file has a header line in here. Then for the enzyme list, we're just going to do the 5 major cytochrome P450s and AOX. You can also do counts. So this would be metabolites of metabolites if you're wanting to produce multiple metabolites. Display intermediates. So these are the defaults. Now this is a new option in ADMET Predictor 12, and it allows you to give your own name or some base name to the output molecules. So here we're going to call it _SIP_. That's how they'll be named. I'll show an example, and then we're going to create a PNG file of the output. So I'll just save this as -v1. So one of the nice things you can do on the command line is specify the file And then you can use this -P option. What that does is simply prints out all the non-commented lines in the file. So now we see all our options here that we specified, and we can just go ahead and execute that command. So now we leave off the -P here, and it goes ahead and produces the output files. So let's take a look at what we've got here. The PNG file, this is going to have the images, the output SDF file, and log file. So if I just start Explorer, and then when Explorer starts up, I'll just double click on the PNG file, and you'll see here that it created the metabolites and it named them properly. So B1 is the base name of the parent molecule, and then _CYP _1, 2, 3 for those products. So that's a nice way to run from the command. So another option is to just point to the input text file, but then specify all of the options on the command line. And the way you would do this, so I'll just look at the original file, the text file, and print those lines out. And then repeat the command. And then if I, for instance, the structure file, I can copy that and paste it, and then just put this on the command line, parent.smi. Then similarly, we'll do the log file, and we'll just place it in the same directory. Then similarly, we want to get the output file, and we're going to call it metabolites.sdf. I don't think the dot is necessary. Then for the name field, we want the name field to be number 2. Then the smiles header line, we have a header line. And then the only other option we're going to specify is this name here, underscore. Then we would just hit the return, and now all those are on the command line. And that's sometimes a nice way to invoke the command without having to edit the file. So you just kind of put the file name and etc. on the command line. So the next section is to look at running command line in a Linux environment. The ADMET Predictor Linux installation files are on ShareFile, and I'll go back to previous version 11 and then go into the ADMET Predictor v11 Linux files. And here you'll see the tar.gz file. So this is the main ADMET Predictor installation tarball, essentially. This is the PDF guide, and I'll talk about this one. And then for ADMET Predictor 11, we have this other binaries directory. So these are binaries for specific Linux operating systems, Red Hat Release 7, and then it's a static and a dynamic version of each. In the current version, ADMET Predictor 12, what we've done is we've just included those in the tar.gz file. So I'll show those files once I extract the file here. This is the ADMET Predictor PDF file for installing ADMET Predictor on a Linux operating system. So you're going to need, obviously, a Linux operating system with standard user accounts. And you need Flexera. Now, this can either run on a Windows machine, some other machine, or you could run it on the Linux machine itself. So we've included 2 files, LMComposite and LMGRD. I'll talk about those in a minute, but those are for the Flexera licensing system. You also need to get the Linux standard base core packages installed. So those can be installed with sudo apt-get install lsb core. And then the first thing you do is download the tar.gz file that I just showed on ShareFile. So you would use this command to extract the tar file. Now, the first thing I want to caution against is simply copying this line and then opening up your Linux and issuing that command. What it is this dash is not copied quite right from the PDF, so it gives you an error. So you need to just put that in by hand, and then it'll extract the zip file and the tar file into a directory called ADMET Predictor v12. That takes not too long. This file is not too large, about 390 megabytes. Then let's go back to the direction. So we've done that now, and then we need to go into that directory, and we can issue this lm composite command. So cd ADMET Predictor /lm composite, and this will give the composite ID. So if you wanting to run the Flexera on this machine, you would send this to our licensing department. You'd get back a license file, and then you'd run this lm grd command with the -c option, and you'd point to a license file. So that's what it essentially says in this line of the directions. So you should have that running. Now, to actually run the program, we have a shell script called run AP. So let's take a look at that shell script there. Okay, so we'll take a look at this run AP script. So the first thing you need to do is set the path to ADMET Predictor, which is the ADMET Predictor _ v12. So I'll just get the directory that I'm in and then load it here. Now I have, as you see, I've got some spaces in this name. So there's a space there. So it's best to put it in double quotes, and then the key is at the end of the line you have to add the slash for the path there. And then this is points to the license file. So for me, that's 2701 at 165.33.3. Now you can, if you want to run with more than one thread, you can change this. So previously I was using 7 threads. You can comment that out if you get some some errors that might help the diagnostics. And then also, since I've got spaces in this, I want to put this in double quotes here. And then the ADMET Predictor, whatever executable you want to use. So for example, on my machine, I've got Ubuntu 18, and I'm going to use the static version here. Then you can save that file, and then you just run it. I'm just going to use the -h option to output the help message. That's basically the way you do that. And then, as you saw in the run HS script, this $score or $* will take any arguments after the run AP, like the -h, and then feed them into the executable. So the example in the manual that we usually use is just run ap.sh, and then -t smi, and then demo2d.smiles. And then you would just run that, and if you produce the demo2d.dat file, that means everything was successful. So that's it for the ADMET Predictor command line video. I hope you've enjoyed this and learned something. Take care. Bye-bye.